Okay, hello everyone. It's me, Joey B. Okay, welcome to the live stream. My name's Joe Barnard. Thanks for tuning in. If you're not sure what we're doing today, we'll get into that in just a second. But let me first say, everyone needs to just take a quick little chill pill because this is the first live stream I've done since the channel has gotten a little bit bigger. And wow, I was kind of unprepared. It's crazy in the chat right now. So here's the deal. Here are the rules. The number one rule is be nice, be respectful. Try just to not be that mean. And try to just chill out a little bit. I've turned on slow mode. That should help a little bit. And that's what's up. Anyway, so thank you very much for joining. Let's check out the chat and see what's going on. Oh my gosh, it is crazy. Okay, hi from Spain. Where's everyone coming from? You should put where you're coming from in the chat. The Earth is... Okay, great. Oh my gosh, this is insane. So today what we're doing is we're building the Scout D series rocket. Now, so Scout has been around for a long time. Scout was the first vehicle that BPS.space built. And we're going to be building a variation on it. That's what the D stands for, is just a... what do you call it? Alphabetical progression. So the A series, actually what we could do is we could bring up some photos here. Well, no, I'm not going to make anything more complicated than I need to. What I am going to do is move over to the workbench here. So let's make sure this works. There we go. You'll also see there's a printer cam. That was printing 2 minutes ago, and it stopped because I took too long to actually start the stream. Okay, it's a little crazy in here, but basically these are our core materials for building the Scout rocket. We've got some landing legs here that I've printed. I'm going to go ahead and reset the printer in just a minute, and we'll start printing some more landing legs. But we've got some body tubes. We're actually going to be using 3 of them, so there's another set of body tubes over there. This is the top coupler. This is the assembly that's basically going to deploy the parachute. And then this is a bottom coupler. Basically, we're going to have a separate avionics section for the rocket. Kind of like how the older Scout vehicles look. So, let me... I also have, getting over a cold, so if I cough a little bit, you'll have to excuse me. Hi from America, hi from London, hi from Greece, Illinois, Arkansas, New Caledonia, Cleveland, El Paso, United States, California, California's capital, where else? UK, Wales, Italy, oh my gosh, Britain, Reading, Pennsylvania, Ontario, Canada, the Netherlands, North Korea, that seems unlikely. What else do we have? California, Wales, Costa Rica, Germany, Brazil, Germany. That's crazy. There's a lot of people in here. So, okay. We should get started with building. The first thing I'm actually going to do is I'm going to restart the printer with those landing legs. So, hang tight for just a second. There's no microphones in the other room where the printer is. Hang tight and we will get that printer started again. So there's something interesting going on in this stream while I just spew words out of my mouth. I'll be right back. Hang tight. Hi everyone from the other room. There's 1, there's 2, and we're going to print leg. Excellent. Okay, we're back. We've got 2 brand new legs here. I'm going to put these over here. So the first thing I think that we're going to start with is we're going to cut out some sections for our body tube. How do I deal with this how am I going to deal with this chat? This is kind of out of control. I have no idea how to figure out what messages to look at. There are too many at this point, even with slow mode. What about a hybrid rocket motor? Well, that's not what we're building today, but I will address that. If you're curious about why I don't use hybrid rocket motors, or I don't build my own, you should look at the propulsion types video on the BPS.space YouTube channel. I sort of go into detail about hybrids are actually more complicated than they seem. So let's get this stuff out of the way here. What is everyone else doing tonight? Is anyone else building rockets? Also, check out my sweet fisheye lens on this camera. That's like tapped against the lens right there. Isn't that kind of cool? All right, so I'm gonna get a third body tube section. Oh my gosh. I didn't even address the most important part of this, which is why are we building a new rocket? So, like, you're on this YouTube channel, you've seen that the Echo rocket exists, you've seen that, like, there are rockets that can be used for these things. So why are we building Scout, right? And, like, is Scout gonna land? And all of these valid questions. So here's the deal. I started the BPS program with the Scout rocket, and I want it to be the first one to actually launch and land in one flight. So that's why we're, like, bringing it back online. Is the Echo program has been doing a great job of testing out just the landing part of the flight, but Echo hasn't actually launched, really. It's just dropped from a drone. And I kind of want to have a new rocket to actually test out the launch and landing, like the full sequence of events for these flights. And I want that to be Scout, because I like the way it looks, and it's kind of just special to me, because it's the first one that I built. Oh my gosh! Woof! There's super chats! Oof, this is a new thing for me. Hi Charlie Welland. Hi Joe, is there any update on when the Signal R2 will be available? Signal R2 is the thrust vectoring kit from BPS.space. It has been sold out for almost a month, or maybe over a month now. But the good news is, just today I put in a massive order to get like production back online. So it should be back in stock within another month or so. But I want those things to show up because I don't want to sell kits that don't exist yet. That seems like a bad idea. Okay. Oh my gosh. Justin Johns, thank you so much. And Ben Tong, you as well. No questions. Those are just super chats. Well, thank you guys. It's very kind. What 3D printer do I have, and do I recommend it? You might be able to see it in... Oh, I guess you can't see it in the shot. Well, it's a Prusa i3 Mark II. It's a gorgeous printer. It's like so good. That thing, I think I probably paid, what is it, like $600 for it or something like that. Yeah, okay, it looks like we have to add some moderators here, but I think I got it for about $600. It prints like 2 or 3 times worth that much. The Prusa series of printers is brilliant. Totally recommend it. Okay, hold on. Let me just do some quick housekeeping here and add another moderator. 1 second. All right, so I mentioned earlier we're going to have a middle section in the Scout rocket because each of these tubes is not quite big enough. Let's see, can I tilt this up a little bit? I'm gonna move this back. Okie doke. So, I also haven't done a live stream in a while, so this might be a little rough around the edges. Hey, it's Eric! What does Eric, I see what you're doing there. What does Siri call me? Should I ask? Leave it in the chat if you think I should ask. If you think I should ask Siri what my name is, I want you to leave it in the chat. Oh boy. I'm not getting out of that. Let me get 2 more rocket cradles. I'll be right back. Okay, so we've got 3 tubes here. We're gonna call this one the top one. I also just want to make sure, sometimes they get bent a little bit. Oh my gosh, ask. Don't ask. Ask, do it. All right. Ready? Hey Siri, what's my name?
You're Joe, but you asked me to call you Big Papa.
There you go. Is everyone happy with that? Is that, in the words of Marquez Brownlee, is this what you wanted? Okay, we need a measuring tape. So this is the top tube. It looks a little beat up, to be honest. I'm gonna see if I can find a better looking one. This one is a little bit beat up too. Boy, they all kind of have like small imperfections. Hold on 1 second. You know, you kind of want to start with like the best looking tube that you can. All right, here we go. I've got some extras. I have like 20 of these at my house at any given time. Your boy just has too much cardboard tubing. That's really what it is. Okay, this one's a little warped, but if we're careful about it, I think we can probably get it back to normal. Oof. Man, don't get a cold. 0 out of 10 experience, honestly. Not that much fun. Okay, I think this is probably gonna work. It's just a little warped. All right, that's a good tube. That can be the top. This one is in pretty good condition, so we can make this the bottom. I'm gonna put this over here for the bottom. And this one looks fine too, so this will be the middle. Okay, we don't need these. How's the audio and the video, everyone? Is it like acceptable? We're not working on like crazy budgets here, but okay, I've missed some chat. I've missed a lot of chat. Arsenio says, update, please help. Arsenio's the mod. Please be nice to him. Joe, can I help with the coding, with the development and coding side? From Hello. Well, thank you for the super chat. I am all set on the coding side right now, but I think later in 2019 we might be looking to bring some more people on board. If you're seriously interested, only seriously, you can shoot me a message on the contact form on the website. Okay. The Art of Sniping says, any news on BPS merch? It's coming. It's not a huge priority, but it's on the way. It's one of those things where, you know, like Joey B is one person, so you kind of have to manage the task that you take on. Audio is fine, video is a bit blurry. Yeah, that makes sense. Okay. Hey, Jared, hold on. Where's Jared? Arsenio wants Jared as a mod. Here he is. 1, 2, 3, add moderator. Okay, great. Hopefully that helps. We're just going to try to add a couple new moderators. If you're a nice person, please become a moderator. All right. We've got the top of our rocket, and we've got the bottom of our rocket. Now, I think the way that we're going to do this is we're going to define how big the middle section has to be based on the flight computer that's going in there. And that is the signal flight computer. So let me just grab this here. This is the signal flight computer, and we also need, what do we need? Oh boy, my memory. Avionics mount, 1 sec. Okay, here we go. The other benefit of running a rocketry store is you just have access to like a bazillion parts all at once. So, get some new avionics mounts, put this bag over here because we don't really need it, grab some extra screws. Okay, 1, 2, 3, and 4. So what we're doing here is I'm just going to mount the computer in these mounts. Then we're going to screw it in. Can everyone see? You can kind of see. It's really hard to run a stream. It's really hard to run a stream all as like one person. So you're going to have to like bear with Joey B a little bit here. We have 500 people watching. That's crazy. Kind of insane. Thank you all for joining. Okay, there's that. And there's this. All right, so this is our flight computer. This is what's going to go inside our rocket and keep it straight. It's a little loose, actually. That's surprising. Well, the good news is usually when it sits in the rocket, it won't be so loose. And it's fine for now. This is basically just a placeholder, so we can fix this later. So, all right, here's what we have to do. Let's get a pencil, and that's going to be sharp enough. Basically, what we want to do is see where this thing can actually sit safely in the rocket. Oof. All right. We're going to take this off of the rocket cradle, and the thing that I want to do is measured from roughly halfway on this. So if we measure this guy, they actually build them in inches. These are, I hate working in imperial, but like sometimes you have to. So 3 inches is about here, which means it's going to sit this far down in the tube, which means the flight computer can safely be, what, like right there, which means we need a second one below it. We'll leave a little space, and it's basically going to be right there-ish. Now, where is that close to in centimeters? Because the rest of the rocket happens in centimeters. 25, so it's going to be 25 centimeters from this side. I'm going to put a little arrow. If this doesn't make sense, it will in just a second, so you'll have to stick with it. But basically what we're doing is we're going to first cut out the middle section and then work backwards from there to make this vehicle roughly 110 centimeters tall. Because that's just what I'm going for. That's more of an arbitrary measurement, but it's what I planned it to be. You got to stick to the plan. Okay, so we're going 25 all the way around here. This is not super precise, but like close enough. It's not rocket science. It's model rocket science. You can get away with a little bit more on the model scale. All right, here we go. 25 all the way around. Just making little tick marks, and then we'll connect them in just a moment. Here we go. And excellent. Okay. Now, I'm just going to go ahead. Oh, you know what I could do? 1 second. I'm going to grab a piece of paper. This is going to help us a whole lot. Let me also look at this chat because this is still kind of crazy. All right, we're down to 490. This is a little bit more manageable now. Have you heard of the Astronomical Research and Rocketry Organization? They do similar stuff to you. That's cool. I haven't heard of them, actually. If BPS current vehicles could only fly for a few seconds, how does he expect to fly the thing really dang high and then re-land it? I think you misunderstand the point. The point isn't to go really high. The point is to go just more realistic at this like small scale. I'm not trying to go crazy high up. Okay, what else? When will we see the next landing attempt video? Love your work. Thank you. The landing attempt is coming at some point. I would love to get one done by the end of January, but it's all contingent on doing a lot more work to update the code base, and I don't think the rocket needs any repairs, so I think it's just the code base. And the main things that I want to work on are the horizontal translation stuff, and I wanted to smooth out some of the barometer readings. Basically, you can get away with a low-quality barometer if you do some fancy filtering, so we're going to implement some of that before the next test too, so we just get more accurate ignition timing. Oh my gosh. What fuel are you using? Solid fuel, mostly black powder. Can I calculate delta V for an F9 mockup? Not really interested in that. Okay. Hello from Australia. Hi. Any updates on ARC? I'd love to buy one instead of a Raven. ARC is kind of chugging along. It's kind of doing its thing. Yeah, it's like, it's another one of those things where as one person, you just kind of have to like pick your battles. And ARC is not a battle that I can fight right now. So we're hoping to get it out by the spring. It's like mostly there though. Honestly, it is really just about time. You know, I need about a month and a half more work of just engineering on it, and then it should be okay. Are you writing those filter libraries yourself? If not, what library are you using? I'll write them myself. Are you going to launch the Scout for fun, or do you have another plan? It's all for fun. I think the question meant to discuss total orbital flights. So really high. Do you think grid fins will work at the scale? No, and I have proof against it. Both CFD and real world proof. Looking forward to the results. Okay, how will you land the center core? With a motor. Why not start a rocket company? BPS is a company. We are a registered LLC. You should say happy birthday to me. It's my birthday. Happy birthday, Austin. Okay. Can you lower the comment timeout? I want to answer people's questions but can't post. No, the comment timeout is going to stay where it is. It's already a little bit too much for me. Okay, what CFD package do you use? I don't use CFD for most of my rockets. And I do want to try open foam though. I think open foam looks pretty cool. Was the Prusa i3 hard to construct, or did you buy it pre-built? I bought it as a kit so that you build it yourself. Honestly, it was pretty hard. Like, it took a long time to build. I think I would rather pay the $100 to just have it be pre-built. Although it was cool to build it once, it took like longer than I wanted to spend. Because the thing is, like, I'm using it, like, BPS is work for me at this point. So it's different when you're building it as a hobby thing than when you're building it and also losing money because you can't spend time on the work that you need to be doing. So I probably would have spent the money to just buy it pre-built. Okay, what was I going to do? Get a piece of paper. I'll be right back. Hang tight. Okay, everyone. I'm sure you might be wondering, what is Joey B doing with this piece of paper? Okay. I'm getting another request for a mod, and we're gonna hook that up right now. Hold on one second, everyone. Eric Spittle, where are you at, man? Give me a message in the chat. Here he is. Okay, one sec. And Eric, you are a mod. Good luck. So what we're doing here, I mentioned what is Joey B doing. Let me show you. What I want to do here is basically just create a straight line to work with. This is like pretty simple. I'm talking about it as if it's something super complicated, but it's really not. We're just making a little straight edge so that it's going to be a better cut, so that when these tubes fit together, there aren't a ton of gaps in between them. Okay. And that looks fairly good. So I'm going to tape this down, roll it real tight. And we're going to do 1, 2, 3. Excellent. Now we're going to draw a little line that we can cut right on the edge. And then I think we'll probably just remove the paper. I just want to draw the straight edge. I don't necessarily need to cut along it. But the line is really going to help us with that. Okay, there we go. There's the line. Joe, how far do you intend to take your rocket company? I don't know, man. I'm having a lot of fun and it's working. So I kind of intend, I mean, this isn't like the answer that people want, but I kind of just intend to take it as far as the project will scale. Yeah, I'm having a ton of fun and I want to see how far I can go. So the sky's the limit, space is the limit. You should ask everyone to say something, and 5 seconds later the chat is calm. It's a good way to handle it. Can you launch a scale Tesla payload and parachute it down? I have done that. Well, sort of. I launched it on the Falcon Heavy, and it didn't really deploy until, like, I don't know, 5 meters off the ground as it was falling. But the Roadster will fly again. Do not be worried. All right, so now we're going to make, talking about like this as if it's surgery, but we're going to make the first incision here, which is just sort of a guide cut. This doesn't actually need to go through the airframe. It's just going to be helpful for the knife to travel along this little guide. Okay, so we've done about 1 revolution. Now we're starting to cut through the airframe. This is a nice, smooth cut. This is exactly what we want. And mostly disconnected now. Excellent. Okay, so this is our midsection of the rocket, and if you're wondering, hey, what will this look like when it's done? 1 minute. So if you're on Instagram and you saw the thing that I posted the other day about like which Scout rocket do you like the best, this is the midsection from some of the later Scouts. And this is basically the same theme as what what was I going to say? This is the same look as we're going to have for this type of thing. Obviously, it's a slightly different size, but it's going to have those roll stripes. The in between the sections, we'll have one of these little indicators for which side, 1, 2, 3, or 4, the rocket is on, and then we'll probably place some cameras on this section as well. But that's just a heads up as to what we're actually building. Okay, now, what else? We're going to call this the top. We're just going to start loosely fitting things together. This is the actual top of our rocket. This is the parachute section and the reorientation fin section. So there we go. And then this is going to be the bottom section of the vehicle. Please mod my dad. What's going on? Arsenio, what's going on? Please clarify. Oh my gosh, this is crazy. Everyone chill out. Oh my gosh. Oh, my dad is in the chat. Mod him. Okay, hold on. Oh dear, this is insane. Hold on 1 second, folks. Thanks for bearing with me. Oh my goodness. Okay, I can't find anyone. There's too much. There's too much going on. Yeah, the chat is crazy. All right, we're gonna build the bottom section now. But, like I said earlier, this piece is too long. It's too long. The piece is too long. Does everyone understand? This piece is too long. Okay, I'm losing my mind, and the stream has been going for perhaps, I don't know, 20 minutes. Now, we've got a big old long tube here. Big long tube. And we need to cut it down. So, like I mentioned earlier, we want 110 total centimeters. Okay. And right now we're sitting pretty at about 117, which is too long. We do not want that many centimeters. So we're going to cut them out of the bottom section of the rocket. Oh my goodness. Just making sure things are going on in the chat. Hold on 1 sec, everyone. Aha! Here we go. And done. All right, you're welcome, Arsenio, just did it. Now we're gonna cut the bottom section of the rocket, so let me put this over here because we don't need it. And let me make sure I can kind of keep up with things here. You should make the SpaceX autonomous drone ship and try to land something on it. You know, there's a pool at my apartment complex. Just saying. And there's a lake near the launch site, so like, we have the opportunity to land things in some water. Okay, so this is the bottom section of the rocket, and we're gonna cut 7 centimeters off of it. That is what I figure. Where's our little straight edge? So we're gonna measure 7, and how are we gonna do this here? Is everyone finding this interesting? I think we're kind of losing viewers. Like, it's cool that we're losing viewers because it's a little bit of a mess right now, but I hope this is interesting for folks. And I'm sorry I can't reply to all of the chat, but I'm mostly here to build this thing, and I figured I'd just kind of turn the camera on because it might be interesting. But keep posting questions, and if I don't answer it on the first time, I'll try to get it around if you end up posting it again. What am I 3D printing? Landing legs. You're almost up 10 sebs since the start. Your boy Joey B coming up. Okay, how high have you flown a rocket? The highest I have flown a rocket is Thrusty McThrustface. What's Thrusty McThrustface, you might ask? Ooh, sorry neighbors. Here he is. Thrusty McThrustface. The best rocket on the face of the earth. It's huge. It's massive. Anyway, how high did it go? I don't actually remember. It went really high. I think it's actually going to fly, it flies on, it's my L1 rocket, so it's a level 1 certification flight. But it went really high the last time. I think we're going to fly it again in like maybe 2 weeks. But I want to redo the L1 certification flight. I got the L1, I just like didn't submit all the paperwork. It's whatever. And I'm going to redo that, and then we're going to go for the L2 on the same vehicle, which should be pretty cool. So we're doing the same thing here. We just want to have a straight edge. Just going to tape this down, fold it over, and voila. Let's draw a line around it. Can you do a bleep blop parts list? Blip blop. Can you do a blip blop parts list? Yep, there's already a part list. It's part of the files that are available on Patreon. It's all like links to where to purchase everything too. What CAD program are you using? What slicer do you use? And what material am I printing in? I use Onshape as my CAD program. I use Simplify 3D as the slicer, and the material is PLA, or polylactic acid. If the rocket uses solid fuel, how do you land after it flies? There are lots of videos that cover that. Where can I see the launch? On the YouTube channel. Go search for Thrusty McThrustface on the YouTube channel. Or just level 1 certification. Okay, hold on. Do you have any tips on transitioning from the lower level rocketry to the next level? I'm interested in advanced rocketry and just don't know where to go from. The best advice is to pick an aspect of rocketry that you really like and then like just laser focus on that. I find that having a super clear goal as opposed to that you just want to advance, having a clear goal is usually pretty helpful for that. Are you planning on making and selling a launchpad kit? Yes, it's just another one of those things that like, you know, there's only one Joey B, so like, gotta focus on one thing at a time. Hopefully in 2019 though. Are you using a Kalman filter for your position estimation? Nope. I am not. Hi from Russia. Hello. What are your goals for 2019? It's probably too much to get into right now, but a lot of bigger rockets. Calculate, okay, hold on. Put a small Lego character in your rockets for no apparent reason. I like that. Okay, hold on. I'm putting more mods in here. Where's Greg? Love the enthusiasm. Really love when people are passionate about their craft. Thanks, Greg. You are now a mod. Okay. Hey, Joe, do you think it'd be physically possible to launch and propulsively land a tiny rocket-scale Dragon 2 capsule? Maybe. I think physically a lot of things are possible, but it gets really tough. Oof. It gets really tough at the small scale to deal with things like wind. That becomes a really big problem. Oh my gosh, how can I keep up with this? Okay. This is crazy. Let's draw some lines. So once again, if you're just joining us, we are building the Scout D series of rockets. So the first one to launch will be Scout D1. And Scout is basically the first rocket that will launch and land propulsively in the same flight. So like Echo, if you've seen the Echo rocket tests, Echo is the one that has been just dropping from a drone. And that's cool. Like there's merit in it. There's a reason that I want to test like that. But of course, once it lands from a drone, we can start to move into more cooler things like launching and landing at the same time. So you can think of Echo like the Grasshopper or F9R test that SpaceX did. And then the Falcon 9 is Scout, really. Scout is the vehicle that will be doing all of that, and that is what we're building right now. Okay, so we made our marks. We're going to cut this now. I hope everyone can still see on the camera. It's a little blurry. Thank you guys for dealing with that, but, you know, do what you gotta do. If you want Joey B to get a better camera, you can donate on Patreon. All right, here we go. Oh, that wasn't a very clean cut. Still going. Ah, these cuts are not good. Still going. There are cleaner ways to cut tubes too, I know. I'm just not doing that. Okay. Now we're really making progress. Should be off in just a sec. Almost there. Aha! Excellent. So we have this now, and this should be the full final size of our vehicle. Yeah, this looks pretty good. Looks pretty straight. Looks pretty solid. The gaps in between the first bottom section and midsection are a little, they're not great, but they'll be okay. Okay. Ooh, thanks for the super chat, Ben Brook. Okay. Now, what else? So we've got the bottom. Does anyone want to see? This is the bottom, like the base section of the rocket. This is what holds the landing legs. This is what keeps the bottom of the rocket protected when it hits the ground. And it's also what interfaces with the launch clamps on the pad. So this part's going to go at the bottom right there. And then you have the rest of the rocket as it goes up. This is going to be huge. All right. So we've cut our airframe sections. What do you think is next? I think we should drill some holes. It seems like that would be a good idea. Yeah. Can read some chat first too. Thank you for bringing so much informative and interesting content, Hart. I hope that you will someday actually land a rocket. Thank you so much. What else? Do you play Kerbal Space Program? If so, where have you been, and is Jeb still alive? My Jeb is long gone. I'm so sorry. Jeb, I sent him on a mission to the moon, and he has not returned. So we're very worried. We're not really sure where Jeb is at this point, but I do play KSP. What is the target overall length of this rocket? So the body section, at least, is 110 centimeters. And actually, we haven't truly checked that yet. 110 on the dot. Excellent. What type of material are those tubes in? These are just cardboard paper tubes. They're pretty standard. I got them at Apogee Components. This is not sponsored. Yeah, they're just standard cardboard tubes. At this scale, you can afford to like make decisions like that. These are super, super light. They're really nice. Do you plan on adding multi-gimbal support to your flight computers? Eventually, yeah. Here's the thing though, like no one actually understands just how hard it is to get a one engine, like one flight computer setup working. It is so unbelievably complicated of a control problem. Like, it does not seem like it would be that hard, and it totally is that hard. So it gets way trickier when you have multiple engines, and I just try to encourage people, like, just start with one. Like, don't get too crazy with it. Okay. What 3D printer are you using? And it is a Prusa i3 Mark II. We need to drill some holes, ladies and gentlemen. So let's take this out. We'll start with the top section. And pretty soon, Joey B is going to have to take an intermission because I need some tea. That's like a pretty constant staple. If you're new here, one of the best things about these streams is that I make tea during them. Okay, so this is already a used parachute section, if you can see, by the way. There's some black powder dust on this because the ejection charge is fired at least once. But that's okay. We don't need anything super complex. So, what are we going to do with this? Well, we need to drill some holes, and I think we're going to drill them like off-axis. Because we don't really need these pre-drilled holes. I just want to drill new ones. And so the way that we're going to do this... Okay, I think I know how. I think, honestly, I'm probably just going to wing it for the most part. So we're going to start by just drilling one and then work outward from that. So the way that we're going to do this is the distance from the center of the tube. We have to do this in inches again because it's all in inches. The distance from the center of the tube to the outer edge of the tube is 1.5 inches. And that is where we're going to put our screw holes. Oh, no, maybe we shouldn't do that. We should do just 1 inch. Because the other ones are at 1.5 inches. So just 1 inch for these holes. Yeah, that's how we're going to do it. Okay. If this doesn't make sense, don't worry, it will soon. So we're doing 1 inch marks. And we're going to do them at the halfway point, roughly in between these two. And it doesn't matter if that's not perfect. And it's not. Okay, so there's our first mark right there. Now we need some drill bits. We're going to take something much smaller than the M3 screws that we're going to be using. Or I think they're M2.5. Okay. And we're going to drill a little pilot hole here. Everybody ready? Okay. Now we need to put a screw in there. Oh, actually, you know what we could do instead is start making marks. I want to do that instead. So we're going to grab a Sharpie here, and we're going to start defining the sides of our rocket. Okay. Oh boy, there's a lot of timing out going on in here. Everyone chill out. Where did you learn to design your own board? I'm talking about where you learned to use all the components correctly. Honestly, I learned a lot of it from Arsenio in the chat. Arsenio Dev gave me a little crash course on PCB design. And then from there, you just like look at forum posts, look at YouTube tutorials, and just kind of try to figure things out yourself. A lot of it is just trial and error, TBH. But Arsenio's little crash course was great. Okay, so we're going to make a line here and a line here, and we're going to label this side 1. 1 and 1. And we're going to do the same in here. And this is called 1. And this is going to seem kind of exhaustive. You're going to look at this and be like, why are you labeling everything so thoroughly? But here's the thing. It's way better to be more thorough, and over thorough, than it is to be really ambiguous and then put things together the wrong way, and then your rocket doesn't fly very well. Okay, so this is our first screw, and now our coupler is attached, but we need 4 of them, not 3. Oh! Okay. I need a guide for these screws. 1 second. Okay, here's what we need. This is a guide. I make guides that go with my rockets so that I can assemble them perfectly every single time. And it's important to do that because you want to be able to assemble your rocket pretty much perfectly every single time. And it is important that all of your sides line up. So that's what this guide is for here. So we're going to put that there. And then we're just going to wrap it around the airframe. Like so. Make sure it's nice and tight. And now all of our screws will be mounted evenly because each letter here, let me zoom in. Each letter, oh boy, I don't know if this is going to work. Let's see if you can see this here. Yeah, so each number right here basically corresponds to an exact side of the rocket, and they're spaced out exactly correctly. So I've got number 1 here, and then we're going to fix them up for number 2, 3, and 4. Anyway, that's what I'm using this guide for. So we're going to do number 2 right here, number 3, and number 4. And I'm just making rough lines because it doesn't matter exactly where they are yet. I'm just marking the actual sides of the vehicle. Okay, and now we're going to make the measurements and determine where exactly these holes need to go. Once again, we're going to make them at 1 inch from the seam, which is right there. There's 1. And gotta be meticulous. There's 2. And 1 more here. 3. Excellent. Now we'll use the drill bit and we'll drill 3 more holes. I'm sure I'm missing a whole lot of questions here, and the view count might be displaying that as we peter on down to 380. I do not think I paid attention. What exactly are you 3D printing? It should be becoming clear at this point, but they are landing legs. And mostly they are support material right now. Okay. Let's see. What else is going on here? Is your printer on carpet? I feel like that's not the best surface for a 3D printer. Yeah, it's not the best, but it's also fine. I live in an apartment, and I don't want the vibrations of the 3D printer to translate through the floor, so carpet is actually a decent option. And I mostly just want a flat surface too, so it works fine. Can you do a collab with Aero Astronomical Research and Rocketry Organization? I don't really know them, so it's hard to do a collab with them because I don't really know them. You should add in the description your 3D printer. I don't really want to do that because if you look at it long enough, it says original Prusa i3 on the thing, so it's not too hard to figure out. Can you stream on Twitch in the future? Nope. I did Twitch in the past, and I don't like that Twitch doesn't save the VOD for a long time, so I'm staying on YouTube. My gosh, what are you printing it out of? Polylactic acid, or PLA. You need to get a banner that just says, "They are landing legs." Do you pop out fins at the top of the rocket to help descent stability? Yes, that will happen on Scout. What else? Will you use 2 ascent motors and 1 descent motor for the FH center core? I'm not sure yet. 1 step at a time. I think I need to land a regular rocket before I land anything on the FH. You can upload the VODs to YouTube. I could, or I could just do it on YouTube. So I'm sticking with that. Okay, so we're drilling more holes now. And I don't technically need to put any more pilot screws in here, but I'm going to do it anyway. Here's another one. Here's another one, and there's another one. Okay. There's one. And then I'm just going to drill these last 2 holes at the same time. And the other one. Okay. If anyone is curious, by the way, how I go about building these rockets and you don't want to watch me doing it live, you can actually watch this. There are 2 separate series of videos on YouTube right now of a total start to finish build of rocket. One of them I build the Omega rocket. The other one I build the Rocket Lab Electron model. The first one is called Build Signal Alpha. It's a series of videos. It's 4 videos. And the other one is called Build Signal R2. And that's the both of these are series of videos where I walk through step by step how to go from having tubes to flying the rocket. So you can look those up. They're on the channel. Okay, and one more. Okay, this is good. So this is side 1. Now I have to remember, how do we count these? It goes around the right of the rocket. So this is going to be 2. Let's just mark this here. This is going to be 2, and then 3, and 4. And then we're going to do that on the other side of the tube as well. So we're going to take these out. Thank you, Binbrook. Okay, I'll take this off and then relabel this. Okay, so 2, this is side 2 right here. 2, and then 3, and 4. Excellent. And we're going to do 2 little arrows that say up, up, and another one right here, up, up. Okay, excellent. Now, this is pretty clearly labeled, so we'll do one on the inside of this tube as well. So if this is side 1, right here, and we're going to go around, this is side 2. So let me mark this. Here's 2. This will be 3. And this will be 4. And I'll also mark up and up. If this, again, if it feels exhaustive, that's because it is, and it's good. It's good to work like this, especially with rockets. So our top section is complete. Now we're going to move on to the midsection. So once again, we've got these 4 sides of our rocket. Actually, I'm going to go ahead and screw this in because we've already labeled it. So side 1, right here. Right there. Okay, so we'll screw that in. And we'll do it for all 4 sides, I think. And 3. And finally, 4. Wow, thank you, Robert Hench. That's very nice. You guys can ask questions when you put the super chat in there. You don't just have to donate. It's very nice, but I'm happy to answer any questions you ask for the donations. Paul Barnard says, learn Onshape. It's a great CAD program to use, and I concur. Onshape is awesome. And surprisingly good for being online. Like, you wouldn't think that an online CAD program would be that good, and it totally is. Like, you wouldn't know. Okay, this is not an ad. So let's drill some holes here. And we're going to use the same measurement as we did before, which is 1 inch away from the seam. So first I'm gonna, oh, you know what I could do here? Let's unscrew this. And we're gonna use the straight edge to make a line down the body of the rocket. So that we can try to be at least a little bit straight with this. It's okay if it's not perfect. I just want to try to keep things as in line as possible. Yeah, that's pretty close. Oh, where's my ruler? The ruler's going to be way better at this. Hold on. Okay, so with the ruler, we're just going to draw a nice straight edge here along the side of the rocket. And it doesn't have to be perfect. This one certainly isn't, but that's okay. And again, we're going to start by drilling a little pilot hole that's going to get our tube locked in. We're going to start the hole right here. And make sure it's pretty much in line. Yeah. Okay. And screw this in. And we need some more screws here. 1, 2, 3, and 4. Let me put these ones back. How are the legs coming? The legs are looking good. Looks like they're still printing. No printer jams. That is always a good thing. Okay, now we're going to unscrew this. We're going to do the same for every side. We're just going to try to have somewhat of a straight edge here along the body of the rocket. That looks pretty good to me. And then, oh, we can just use this to make the inch mark too. This is really helpful. I'll make the mark right there, right to the side of it. That looks about right. And then we'll drill. And here we go. I hope this isn't boring. There's just a lot of drilling. It's like an oil rig. All right. Come to the stream with Joey B. The jokes are bad, and so are the rockets. There we go. That's a pretty good line. And then let's mark the 1-inch point. Binbrook, $2. What got you into rocketry? I'm loving your work. Thanks, Binbrook. And thank you, JR Craft, too. So if you want to know what got me into rocketry, there's a really good summary of it on the About page on the website. And it will just link you back to a video called The Future of Scale Rocketry, NARCon 2018. And it's a video where I present my work and I sort of tell people, like, here's how I got started, here's why I got started. And I recommend checking it out. It's a pretty good summary. Some serious lags are going on. I'm not sure if this is my side. What kind of lags? I hope it's not video audio. Let's look. Let me do a little test here. I'm going to turn my sound on. Let's look. Video. Let me do a little test here. I'm going to turn my sound on. Let's look. Video. A little test here. I'm going to turn my sound on. Oh, it's okay. It's not that bad. It's not good, but it's not that bad. All right. Just put this in. And it's not great. The lag isn't great, but also, like, it's not bad enough that I feel like I need to spend time fixing it, at least right now. I can fix it offline later, but we're here to build rockets, so we should be doing that. Okay, this looks good. Draw a little line. Make the 1-inch mark. And we're almost done with the midsection here. Well, the top of the midsection at least. Okay. And one of these guys. And one of these. Okay, cool. Our midsection is attached. Look at it. Man, oof. Feels great. It's super solid. This is good. This is a good thing. Now, what's next? How about a bottom section? And how about a coupler to a bottom section? That is the first part that we need to get right. All right, I'm missing some chat here. From Liam. Wow, thank you so much, Liam. Love your work, mate. Hello from Wanaka, New Zealand. What time is it? Oh, it must be early for you in New Zealand. Or it's at midday? Let's look. What time is it in Nope, not New York. 3:12 p.m. Happy afternoon. Liam, thank you for the super chat. Justin Johns, thank you, Justin. Will this be powered by? Please answer. Oh, what will this be powered by? What will this be powered by? Do you mean like the rocket motor? It'll be some variation of like an F motor from Estes or Apogee or Aerotech, something like that. Oh my goodness. What kind of screws am I using? They're hard to make out in the video. They're from McMaster. It doesn't matter where you buy them, but they are, I think they're 6mm M3 screws. These are them right now. They're just little machine screws, but they're my favorite, and I spec all of my things around them. And there's no particular reason. It's just like the important part is that you remain consistent across your designs. So, like everything that I build, the thrust vectoring mount, the flight computer, the launch pad, like all of the screws in the rocket are M3 sized. What software do you use to simulate your rockets? I use OpenRocket. I'm also working on a wind tunnel. Cool that you're working on a wind tunnel. I use MATLAB, which is a more heavy engineering tool, but it allows for more accurate simulations and a lot more customization than OpenRocket. Why do you borderline abuse your keyboard when you use it? It sounds like you're hitting each key, especially enter. I don't know, that's just how I type. I mean, eventually the keyboard will die, but this is like 5 years old, so the keyboards can take it. And it's more satisfying to just like slam the keys. Do your rockets have a connection to a ground computer, or is it just the flight controller on its own? It's just the flight controller on its own. I have in the past built rockets that do connections to launchpad computers, both electrical and physical. And I generally think it's not worth it at the model scale. I think you end up adding a little bit more complexity than is really worth it, and then is really good, because every bit of complexity adds failure points, and that's what has ended up killing several rockets, is that connection to the launch pad. It's more satisfying to slam the keys. It is. What defines the different versions of your rockets? They used to be a lot more serious in terms of their different program goals, and at this point, the guts of all of these rockets are nearly identical. So at this point, it's just aesthetics. I kind of like rockets that are white. I kind of like rockets that are black. And I kind of like all sorts of different designs. So they're mostly for looks. Could you ever make a Saturn V replica? I'm working on it. It's going very slowly, but I am working on it. Hi from Bangladesh. Thank you. Can you use Signal instead of Blip or Blop? Yeah, I suppose so. Signal is less customizable on the user side, but for me, I can use either one. Will this version of Scout do different things from the other rockets I have made? Yes, well, kind of. This version of Scout will land. It won't land on the first few flights. Like, I would love to fly it as soon as possible, basically, and just launch it like a regular rocket with parachutes. But, you know, one step at a time. And speaking of one step at a time, we need to continue building this thing because we're getting nowhere. Okay, so I've got my body coupler here. And actually, before we do anything, we should make some measurements on this body coupler. So, like the other one had a center point measurement on it. So we're going to have to make that again. These body couplers are 6 inches long. I wish it was in metric, but whatever. We're going to conform to whoever cut these. Okay, here we go. So I'm going to mark 3 inches all around the body tube. And then eventually we'll draw a nice little center point line so that we have a better sense of where we can make our measurements from. Okay, so just marking 3 inches all around this little tube. Beach Swanson. Put fins on the rocket engine, see how high it goes. Also make a rocket that deploys a rover on landing. That just sounds like a regular model rocket. I don't really care about going high and fast. That's a fun game to play, but it's not a game that I play. Well, it is a game that I play with Thrusty McThrustface, but otherwise I don't really care about going high and fast. I like the control systems side of things more. TBH. Okay, there we go. And bingo. So now we're going to draw a little line around the center. There we go. There's a lot going on in the chat. I will look at it in just a moment. Okay. Oh my gosh. Please do SpaceX style webcasts. I can't. I'm sorry. I wish I could, but there's only so much you can do as one person. Hopefully, if we can get like more support, I can hire some people to help with that. But until then, I just can't live stream launches. Will you ever make a suborbital class rocket? All of my rockets are suborbital. It's called Scout D because it's the sequel to Scout B and A. Yeah, kind of. Let's see. How does this work? So Scout A. Let's see. Scout A, B. Yeah, A and B were both in 2015 and 2016. Scout C was in 2017. I did a couple flights of Scout C. 1 second. So here's like an example. This is from Scout C. This is the upper section. And it was actually a smaller sized airframe. This is a 66 millimeter tube airframe, but you can see it says C1 right there. So this is from the Scout C series, and this is D. Metric is far superior, correct. What are the dimensions for the landing legs? That is a little bit too hard to describe in verbal things, but I think they're all about 150 centimeters long, something like that. Okay. Have I ever had a successful landing with the Falcon Heavy? No, I have not. I bought a new printer today. Oh my gosh, love the TNC2. I'm using it for music though. Oh, that's awesome. Yeah, Paul has put in like tons of great work with the TNC series. I really can't believe how awesome it is. There's a new one, the TNC, I think 4.0. It's like in development, but the rumor has it's going to be like several hundred megahertz. It's going to be crazy. It's like not for sure, but it's going to be crazy. Can't you switch the solid fuel tank you buy online to a bigger size tank? I'm not sure what you're asking. Body tube size, BT80. This is a 3-inch body tube, or 74 millimeters. And the one that was Scout C1, that is a BT80. Okay. What do you think of using one or more neural networks for landing rockets? They tend to be very accurate if trained correctly. I think AI and rockets is a terrible idea, just like all across the board. There's like real math that defines how rockets fly, and if you are a customer with a $100 million+ payload flying on a $60 million+ rocket, you want to know every single variable and every single way in which your rocket works. AI and machine learning do not let you see all of the intricate details of how they work, so they are a bad idea in rockets. Ian Stevens, just a big fan of the channel. Thanks so much, Ian. How many lines of code did you write for Echo? A lot. Hello, Joe from Colton. Hi, Colton. Can you start building rocket parts with a 4x4x4 volume printer? Oh, sure. They'll just be 4 inches by 4 inches by 4 inches. how will you land a model rocket if you're using solid boosters? You should look at some of the other videos. There are a lot of videos that talk about this. Okay. When can we expect to see a launch of Scout D? Soon. TM. Soon. Don't try AI with rockets. You need to have deterministic controllers. Yes. Okay. What programming language do you use? I'm almost done, and then we'll get back to work. I use C++ for my rockets, but actually it's just Arduino. Arduino is like a little piggyback version of C++. Yeah. Will your Saturn V model be able to separate into stages? Yes. TM does not mean tomorrow, it means trademark. Okay. I have to stop reading comments because I'll never get anything done. So, we've made our center mark on this little piece right here. And let me go back and make sure everything looks good here. We made our center mark on this little piece, and now, I don't think we have to mark sides yet. I think we have to drill a pilot hole first. My neighbors are getting antsy. They're stomping. Okay. Here we go. This is roughly the center point. It's pretty close. So now what I'm going to do is I'm going to unscrew these. And then I'm going to use this as another straight edge. And we're going to try to just continue the line all the way down. These don't have to be exactly perfect, but they have to be pretty close. Yeah, that's pretty close. And then we're going to make a 1-inch mark right here. Excellent. And we're going to drill the hole. Okay, there we go. That looks good. And then we'll put a screw in there. Where are my screws? There we go. There's one. Okay, we're running out of screws, folks. We need some more here. 1, 2, 3, 4, 5, 6, 7, 8, 9. That should be plenty for now. Okay. All right. Now, we have to do this for the same sides, but, surprise, surprise, it's time for Joey B to take a quick little break. So, we're going to go to an intermission. Do not leave. If you leave, terrible things will happen to you. I mean, just really terrible. You don't even want to find out, so don't leave. And I will be back in 5 minutes? I don't know. We'll see. Very soon, though. So, 3, 2, oh, go to the website that you see. Go to the website. Here we go. Okay, hello again, everybody. Well, I'm having a stroke. Hello again, everyone. We back. It's Joey B, back with the stream. And this time, I have tea now. I made tea, and it's orange. Let me make sure I get it right. It is Orange and Spice Herbal Tea by Bigelow. And, let's see. And it's quite good. I recommend it highly. So we're going to use this tea to continue building our rocket, and let's go over to the workbench. Here we go. Don't spill the tea. Excellent. Okay. I hope... Oh, we lost some viewers. That's okay. I don't really care. Well, like, I care, but also it's probably for the best because it was a little out of control there for a minute. So we're going to keep building. How did everyone like the site, thebarnardbathroomreview.com? I hope everyone enjoyed it. I worked very hard to review those bathrooms. And before you number 2, you should always check the review. Okay, this looks good. So we're going to make a mark here. Oh, that is actually not that good. Oh dear. Okay, hold on. That's okay. It's not great. Oh, you know what we can do actually is we can just base our measurements on this guide again. Let's do that. I like this way of doing it. David Chapman. Thank you for the super chat, David. 10 out of 10 bathrooms. Wood bathroom again. They're good bathrooms. Well, except for, well, there are some that are not. That's the best part about the review, is I try to be unbiased with it. Okay. There we go. Because you use solid fuel engines, have you considered or thought of developing a thrust reversal mechanism so as to modulate thrust on descent? Remarkable progress in such a short period of time. Thank you, Dan. Thank you for the donation as well, too. So, yeah, there are a bunch of creative ways that you can go about actually modulating the thrust in a solid fuel motor. And there are actually some exciting things maybe coming in the pipeline for how to do that, even with solid fuel. A couple of the ideas that people usually pitch are either a thrust reversal system, like you could see on most aircraft, or especially commercial aircraft when they land, they reverse the thrust and shoot it out the front. You could also do something like a what I refer to as cosine throttling or sine throttling, and it's basically you have 2 or 3 engines. It's kind of inefficient, but basically you have 2 or 3 engines, and as you want to, you could like nominally fire them at like 80 degrees vertical, 80 degrees to vertical, something like this. And then as you wanted to throttle, as you wanted to reduce your thrust, you could pitch them out, and basically they would spend their thrust just pushing against each other more and more as you go further and further out. So you basically look for cosine losses in your motors. In theory, that can work. The problem happens when you consider the extremely low mass moment of inertia on the roll axis of the vehicle. So like if you have a rocket, it's fairly hard to pitch it this way, it's fairly hard to pitch it this way. It is extremely easy to roll this vehicle. Like it takes very little force to do that. So any tiny little misalignment that you have in your thrust cosine throttling system ends up like just really compounding with how sensitive that roll axis is on the vehicle. So you also need roll control with that, but you need actually very sensitive roll control with that. So anyway, cosine throttling is a little harder than it looks, and it's not that efficient to begin with. But, okay, and this is all I will say about this, but basically, you can also modulate the thrust of a motor by modulating the size of the chamber that the combustion is happening in. And normally, if someone were to pitch this idea to me, I would say like, that's ridiculous, how can you get such precision, especially at the model scale? Except, there may or may not have been an idea pitch from like a major motor manufacturer that they were like, yeah, we can make this happen. So just like keep your eyes peeled. Maybe that'll happen, maybe it won't pan out, but it seems like it might be possible over the course of like a 15-second burn to have, I don't know, maybe like 20 or 30% throttle capability. We'll see. I'm not sure yet. We'll see. Okay, Joe, wouldn't that crush the rocket? Hold on. Hey, Charlie Garcia's here. Everyone say hi, Charlie. Everyone type in the chat, hi, Charlie. If anyone has seen the propulsion types video that I keep mentioning in the landing model rocket series, that's Charlie from that video. He's here. Okay, anyway, we need to get marking up on this rocket. So let's get our handy dandy pencil here. We have side 3, 2. Peter says, can't wait for the Falcon Heavy launch in a couple of months. Thank you so much, Peter. Me neither. It's gonna be crazy. I still need to fix the center core issue with the motor burning, but there have been like an ocean of good ideas that have come in since that video went out. I mean, it's the most popular video on the channel at this point, so many people have really generously pitched me ideas or their services to try to make a more substantial center core thrust vectoring mount. So I think we're really, there's a high likelihood of that flight succeeding. Flight number 2, that is. Okay, so we're gonna mark 1-inch marks on each one of these sides. And there we go, there's another one. And we need a third. Right there, excellent. Okay, look at all these hi Charlies. Are you an engineering student? No? Depends, I mean, if you count studying by yourself as an engineering student, then sure. I think the right answer is no. But the technical and motivational answer is everyone's a student. Okay, there we go. And we need one more here. Okay, screw time. So here we go. Screw number 1. Screw number 2. Screw number 3. Oh wait, and this is the last one, so screw number 3. Boom. All right, next up, bottom section. I'm trying to line up all of the spirals too. You'll notice like right here, the spiral actually lines up on this airframe. I don't know if you can see it in the frame, and if you can't, I'll just zoom in. Yeah, like the spiral lines up at the seam because #perfection. All right. Overkill is what it's called because it will be covered with paint. All right. So this is looking pretty good. I'm going to line up these spirals as well, just like we did up top. I don't know. If there's no particular reason, it's just kind of fun to do that. All right, let's look at some chat. Hey chat, what is currently being printed on the 3D printer? Landing legs. They are starting to really come into view here. You can sort of tell at this point what they are. I suppose with maybe 15 more minutes, you'll really be able to see what they are. Okay, what else? Yeah, landing legs, hi Charlie, bottom section or bottom text, test. Will you ever make a Falcon 9 replica? I think so, probably. This is pretty close to a first stage size, at least to scale. When did you start rocketry? I've been doing rockets for since I was a little kid, but I only got really serious about it in 2015. What kind of 3D printer do I have? It's a Prusa i3 Mark II, and it's awesome. What are your plans for expanding the company? Just more cool projects, honestly. Just anytime that we have the ability to take on more cool projects, we will. What do you use to edit your videos? Adobe Premiere. It's pretty good. What does your test schedule look like? It kind of just looks like whatever it needs to. Whatever kind of tests need to happen, and then sometimes there's a month or two where I don't need to test anything. That's a lot of support on that print. Yeah, it sucks. It's 90% support material. This is what the final leg looks like. And basically just in order to have all the right parts of the leg not get messed up by like boundary layer things in between the different layers of the print, you really want to print it in this orientation, which means a ton of it ends up being support material. I'm not going to get it off now, but yeah, like most of this is support material. But it does come off pretty cleanly. I guess we could do one now just to show you. So grab some pliers. 3, 2, 1. It's mostly support material, but it is a very clean separation because the print is pretty dialed in. Yeah, there it is. That was like 2 different moves, and now that's a finished leg. Anyway, but it is mostly support material. I would like to be able to just like melt down the PLA and then reuse it if possible. Okay, a little more tea and then back to work. When will there be bigger kits? I'm not sure, sorry. Have you okay, hold on. I'm falling behind. Let me do one more little speed round here. Oh, we're going up in views again. 319 people. That's insane. That's a ton of people. That's a ton of people. Joe, you gotta do composite legs. Yeah. Yeah. That's the yeah where I know Charlie's right, and I don't want him to be right because I have a bunch of infrastructure designed around these legs, but he is right. Composite legs are probably the way to go. If you would get 100 billion, I don't know how many dollars that is, what would you do with BPS? I don't know, man. I have no idea. Have you thought about using higher temp material for your rocket motor mount? I know you had a problem with that. Yep, working on it. Hi Joe, I would just like to let you know you're a huge inspiration to me and keep up the good work. Thank you so much, Keon. Is there a way I can help this company? Printing, modeling, oh sorry, I lost you. Printing, modeling, or anything else? The best way to help is just to share it around or support it on Patreon right now. But yeah, thank you. What do the multiple sections, why do you have multiple sections rather than just one long tube? What is the diameter? The diameter is 74 millimeters. Sorry, that's the length. The diameter is 74 millimeters, and they don't make longer sections of tube like this. And it is easier to deal with the rocket that you can take apart than it is to deal with one long tube. David Chapman, thank you, David, says, what other than thrust control do you wish you could have more control but really can't at the model scale? Ooh. I wish the rockets were heavier, honestly. This is kind of negating the question, but the question is basically like, what is tough at the model scale, and like, what would you want more control over? And I'm gonna kind of change the question and say like, what would you do differently? So the Falcon Heavy, the control software for the Falcon Heavy is really hard. However, flying a vehicle that is so large is actually a lot easier because it's more forgiving in the control parameters that you set. So like, if your rocket weighs 200 grams, most of my rockets weigh more than that, but like if your rocket were to weigh 200 grams and it's going through the air at like 30 miles an hour, that is a rocket that is inevitably going to flip out of control and go unstable if it's not naturally stable. But if your rocket weighs like, I don't know, 40 kilograms and is moving through the air at even like a greater speed than that, you just have a lot more time for the control system to react because it's a more massive object. So that's kind of what I wish. I wish I was working at like twice the size of this, but like financial constraints and physical constraints, like where I live and like the space I have available and all of these other constraints, legal constraints, all of that stuff limits it basically. Oh boy, I'm really behind at this point. I'm gonna skip a bunch. Can you make a DCX model? Probably not. It is a cool rocket though. Back it again with the cool metal multi-tool. Yes. Have you thought of making a new Shepard? Yeah, I think it's a cool rocket. That would be cool to do. Why not create, I don't know what that is, sorry. Grid fins ever? Maybe even not controllable ones? Grid fins have really, at this scale, they have issues with boundary layer ingestion. That basically is getting all of the air to suck through the lattice of the grid fin, and which has to happen for them to really be effective. It's just tough to do that at this scale. So I think the answer is probably not, other than maybe just for show. Okay, we line these up. And now it's time to drill some holes. I'm moving at a remarkably slow pace. So we need another straight edge. And I'm gonna move this over here. I'm just gonna try to get this as straight as possible because this is basically the only one that needs to be perfect. Okay, yeah, that's like roughly the center point. And then we can use this paper again. This lovely, lovely paper. To draw some lines. Oh, actually, you know what I can do? I can measure 1 inch. Yeah, we should probably do this first. We're gonna measure 1 inch and then just drill here first to get that pilot hole down. Okay, there we go. And pilot hole complete. Okay, and with that done, I'm going to unscrew this. And we're going to remark a bunch of things here. So we'll make this as 3. Oh, Charlie for mod. Yeah, let's get Charlie as a mod. Hold on, I'm coming, Charlie. 3, 2, 1, add moderator. Done. Thank you, Arsenio. Good suggestion. Okay, there's that. And then let's roll it over. And bada bing, bada boom. Let's make some lines. 1, 2, 3. Okay, now we need our pilot hole back. Or, sorry, we need our pilot screw back. This is going to help us keep our airframe all in one place. So that when we drill these holes, we don't drill them incorrectly. And then we're going to remeasure where 1 inch is, which is basically at the tip of this. So I might just mark that and then drill it. Okay. A lot of drilling. We're almost done though, folks. Okay, there's 2 screws. We need another one here. How straight is this? Oh, this is fine. It's very straight. Oh, and let's do this. Make sure I mark it correctly. Yeah, it's all at the end. Hold on. I'm sorry if this sounds like nonsense to everyone. Just have to make sure these are all accurate. Whoops! Ah! Uh-oh. Runaway screw. And one more. Good thing I charged the drill. Yep, once again, it's at the end of that line. So we'll drill right there. And boom, done. How's that? Oop, we're missing 2 screws. Hold on. Mayday. Un momento. And we need one more. Right here. Boom. This is feeling great. Man, I haven't built like a new rocket in a while, and I forget just how like exciting it is to have a totally blank airframe and like drill these perfectly. Oh yeah, they are perfectly aligned. This is really good. These are like right down the middle. This is great. I'm super excited about this. Yeah, I like forget how nice it is to have just a totally clean airframe to work with. It's really refreshing. Okay, we need to make some markings on these too. We haven't done that yet. So let's get some water first. I have missed a lot of chat. So let's check this out. We've also been going for like almost 2 hours. It's kind of a long time. Okay. We're going to skip down to the bottom of the chat here, see what's going on. Do I attend college? If so, where? I do not. I did, and then I graduated from the Berklee College of Music. Need a second drill. Do I just have the one printer? What brand of PLA do I use? I think I use like eSun or something like that. It's nothing very good. Although, I mean, it works fine. And do I just have the one printer? No, I have 4. I have the Prusa i3 Mark II, which is the best by far out of all of them. And that's the one that I use as like the main printer at this point. I have a Monoprice Maker Select. That's like the backup printer. It's not very good, but it's a backup. I have a, what is it called? FlashForge Creator Pro. That was the main printer for like almost 3 years. And then it died this summer. So that it's dead, it's kaput. But it was a pretty good printer, although just a little bit overpriced. And then I still have a, what is it called? It's awful. It's like the M3D. Yeah, it's the M3D Micro. Man, that is like the worst printer ever. I hate that thing. It was so hard to get it to work. I just like 2 thumbs down on the M3D Micro. That was the first 3D printer I bought, and it was so bad that it was like 2 months in, I knew 3D printing couldn't possibly be this hard, so I bought a new one, and I was correct. It shouldn't be that hard. Okay, that was kind of a long answer. Have you ever used RockSim? Scott Manley did a shout out of you in one of his videos. Wait, did he really? I haven't seen that. Arrow, what video was that Scott Manley did? If someone wants to post it in the chat, I would love to see it. Scott's awesome. Do I think I look like Elon Musk? Oh my gosh. All right, I'll address it now. Yes, but like, here's the problem with the Elon Musk thing. Like, it's a funny meme. It's like kind of a funny joke, but the issue is like, I genuinely really love this stuff. And the problem with all of the Elon Musk memes is I worry that people will see me and think like, oh, the reason he's doing it is because he knows he can get followers because he looks like Elon Musk. And like, that is totally not the case. I think most people don't think that way, but it bothers me that that's like a train of thought that I have. So I think it's like a funny coincidence, and I think it really just ends there. Okay. Arc Computer Progress, it's chugging along. It should be available this spring. We're still working on it. Okay. Hello. It's Scott Manley. Oh, yeah, no, it was Tim Dodd, the Everyday Astronaut. Tim and I are buds. Okay. We need to keep working here. So what's next? Oh, we needed to label some of these sides. So let's do that on the bottom here. Oh, wait. I think we also need to label them in here. So let's do that. Okay. 2. This is 2 right here. So we're just going to mark up these sides here. Make sure they look good. Okay, so this is 2. And then 3 is here. 3, 4, and 1. Gotta make sure you get all these right. Don't want to mess them up. Okay, then we're gonna reconnect these. There's a lot of screwing and unscrewing, but it's worth it. It's worth it to make sure you get it all right. And 4, here we go. Oh. Which side is which? Wait, did I mark it on here? Maybe I marked it on here. This is crazy. This is madness. Okay, I think I marked... Nope, I didn't mark anything on here. Okay, hold on. Pretty sure that is correct. So we're gonna screw this in and not touch it. Now we're gonna unscrew these because I'm bad at things sometimes. Oh boy. Okay, we want side 1, which is right here. This is side 1. So if I keep that pointed up, basically I just need a solid reference on what side 1 is. And you only have to get this right once. So it's important that you do. Okay, so this is 1 right there. And then we're gonna mark it in here as side 1. There we go, 1. Boom. Now, 1, which one's 2? 2 is to the right. So we're gonna go around to the right. Right here. And that one will be 2. And this one will be 3. And this one will be 4. Okay, great. So we have these marked. This is insanity. 1, then around to the right. 2, 3, and 4. Go ahead and do this. This is side 1 right here. So 1. My marker is running out of ink. Okay, 1, then 2 is around to the right, which means that it is around here. 2, 3, and 4. And then we're going to relabel it on these. 1, 2, 3, and 4. And I'm going to do a little up, up, and one other, one up, and up. Excellent. Okay, thank you for bearing with me. This is getting kind of boring. Okay. Well, it's not boring for me. I just assume it must be boring for other people. So that's side 1. Now we're going to follow this down. Oh, we should probably... at some point we have to mount the TBC and avionics. And that's probably going to be pretty soon. We have these sides labeled. Okay, let me think about that for a sec. Let's look at the chat. Let's do that. Okay. So, ooh, Jen Morgan. Thank you, Jen. Just joined BPS Patreon. Thank you so much, Jen. Hey, this is a great opportunity. If you want access to files and private chat things, and what else do? We have a Discord server. There's a bunch of things. Patreon.com/BPS.space. And maybe one of the mods will do it, but I might beat them to it right now. Here we go. And there we go. Thank you so much, Jen. It's very nice. Okay. All right, let's look at some questions. Glad to be a member. Joe is a very special kid. I met very few as bright as him in my 64 years. I want to see him excel in this endeavor. Thank you so much, Jen. That is really kind. Really appreciate it. If BPS were looking to hire, I would apply. Thanks, Josh. We're not quite looking yet, but I appreciate the enthusiasm. When will the first launch be of the Scout D rocket? Don't hold me to it, but maybe Tuesday. We'll see. I'm gunning for Tuesday. I think it might be unlikely that we hit that, but I'm going to go for it. We'll see. Okay, are you ever going to make a replica of a space capsule like the Dragon? Maybe, I don't know. If I do a replica Falcon 9, I'd probably do a Dragon or something like that. Okay, you inspired me. I created my own model rocket company and called it HSC, Houston Space Company, with the goal of landing a model rocket on a barge in a pond by my house. That's awesome, Matthew. It sounds more like a project than a company, but that's pretty cool. It's stupid, not boring. Pool bow. Bye. Okay. What else? Can you sell flamethrowers? Probably not. Can someone plug the Discord server? The Discord is only for patrons. Sorry. When did I first meet Arsenio? Joe? I first met Arsenio. Okay, like I knew of Arsenio for a while, and we like hung out on Twitter for a little bit. But I first met him in 2016, like as I was testing the really early Scout rocket stuff. I was doing a road trip down to Nashville, and we met at like a Mexican restaurant or something. And then I hung out with him, and we tried to blow up several rocket motors, like about a year ago now. That was really long ago. Wow. Are you a Tripoli member? I am, and NAR. Do a KSB live stream. Maybe. We'll see. Are you going to do a live video for the next launch? Nope, I don't live stream my launches, and it's not like I would like to live stream the launches, but it's just like a lot of work for one person to do all at once. Can someone explain to me what are integrated circuits and how to choose the correct one for certain applications? That is a little complicated for me to explain now, but that might be a question for Google. What is the current print percent? What a great question. Let's look. Let me go check on that. Looks like it is 32% done. 32% done with those legs. He does time-delayed live streams. Not anymore. I used to do those. It's kind of no point. There's not really a point in doing the time-delayed live stream. It's like a really weird middle ground. And at that point, it's like better to just post the actual video. Am I a pilot? No, but I would like to be. It's just expensive. When will you do Falcon Heavy? 2 months, maybe? We'll see. Okay, almost there. Are you excited for the Dragon crew capsule launch? Of course! Yeah, it's gonna be awesome. Have you thought about plotting XY using Excel data and your speed over ground based on angle? Have you thought about plotting your XY using Excel data and your speed over ground based on angle? I think like the answer is yes and no. The way that I'm going to do positional data on the rocket is not directly looking at acceleration, but rather looking at acceleration along the z-axis only, and then factor in the current orientation of the vehicle, and then integrate that over time, which should be accurate enough. We'll see. We'll see is the answer to that question. How much does it cost to make one rocket? I don't know. It really depends on how complicated the rocket is. Are the landing leg files on Patreon? Landing leg files on Patreon. They are not on Patreon yet. They are not there yet. Do not support on Patreon if you're looking for landing leg files only. I mean, you can support, but like, I don't want to mislead anyone. They're They're not there yet because I haven't done the video on landing legs yet. And the landing legs are not in their like final perfected state, so I'm not trying to like give away things that don't work to people. I mean, they work, but like I want them to be better. Okay, I'm almost done. I'm almost caught up. I don't understand any of this, but I'm trying to. Nice, awesome. How close are you to landing a model rocket? Because my company's going to use a drone in the Pluto rocket and landed it. I don't know, fairly close? We'll see. What is the estimated print time on the gear? Another hour, maybe an hour and a half? We'll see. If you donate directly on BPS.space, is there a method to get the Patreon perks? Yeah. It's way better to do it through Patreon, though. Yeah. If you want the Patreon perks, like, you should probably just do it through Patreon. That's probably the best way to do it. Have you tried making a space shuttle? Oof. It would be really cool and also extremely hard. Okay. I have to keep working. So let's do that here. We've got all these things labeled up. I'm going to go ahead and put some of them back together. Okay. And this guy here. And now that we've labeled these, does it make sense? I hope it makes sense to everyone what we did. Like, if you can see inside these tubes, I made labels of the sides, so that when I put these rockets together, we can line everything up so that all of the screw holes will naturally just fall into the right place. I hope that makes sense. I'm not sure if I was really clear about that, but it's important and helpful. Okay, do that. Just gonna try to line up each side. And this side, 1 and 1. There we go. And excellent. Okay, so now it's back together, and I think, ladies and gentlemen, I think it might be time to mount some real hardware in this thing. And the first of which is a flight computer. So let's take a look at this here. We want to really be careful to line these things up correctly, because if we don't, that will be trouble. So let's take this out and make sure it's on side 1. We're going to base everything around the screw being in side 1. Okay, there we go. And do that. And push it together. Okay. Now what I'm going to do, well, I'm just going to be really careful with it. That's how we'll handle this. So side 1, side 1 is like right there. And I kind of just want to split the difference here. Yeah, like that. Okay, let's get a bunch of little pieces of paper, and we're going to tape this guide on here. And this guide is basically going to give us the exact size of the holes that we need to drill so that a signal flight computer can fit inside this airframe section. And I'm going to rip up a bunch of pieces of paper so that we can do this effectively and keep the paper stuck to the rocket. Okay, 1, 2, 3. All right, and you want to get this just as accurate as you possibly can, because this is going to really help determine how well this rocket flies. There are better ways to do this, especially if you're working in the actual aerospace industry. But Joey B is working out of a living room today, so take what you can get. Okay, this is a pretty solid alignment here. So we're gonna put put some more tape on here, like one right there, one right there. That's probably good enough, to be honest. To be honest. And then we're gonna cut around here. Okay. Just joined Patreon so I can slide into y'all's Discord DMs. Thank you, hello. Nice name. Okay. We need to cut some things out here and make some drills. I can't remember which one I like to do first. We'll do the cuts first. So the cutout here is going to let us access our flight computer. And this is pretty important. Let me make some marks actually on these. There's 1, there's 4, there's 3, and there's 2, and I'll make the mark up here too. 3, 4, and 1. Okay, so we're gonna cut out this section right here. See this little red box? This red, oh geez, hold on. This red box is where the hole in the flight computer bay is. And this lets us access things like the power switch and the SD card. It's a bunch of important things, really. So we're gonna cut this out. And kind of want to be careful with this because I'm cutting directly into the airframe through this piece of paper. Can anyone hear the printer in the background? I wonder if you can. Okay, this is going pretty well. Trying not to goof it up too bad. Okay, there's one big incision. Here's another one. Okay, we've got one right here. Oops, that's not a good cut. And that was kind of an okay cut, to be honest. Oh. 3 and 4 and there we go. Excellent. It's not perfect, but like, what are you gonna do? Now, we have these other red dots here. See these red dots? These things, it's really hard to see on the camera. These red dots are where I'm going to drill holes so that the flight computer, see these holes, these red dots correspond with these holes in the flight computer's mounting brackets. So that's what we're gonna drill. It's going to be 8 different holes, so get ready. Two, 3, 4, 5, 6, 7, and 8. Brilliant. I never say that word. Actually, I say that word all the time. What am I talking about? Okay, excellent. So now you can see we've got our holes drilled and cut. And if we were to stick a signal flight computer in here, which here, let's demonstrate it. So if we stuck a signal flight computer in here, it would sit pretty much perfectly in this section right here. And then you'd be able to see the light, you'd be able to see the power switch, and that's how this works. So this is our avionics section of the rocket, our avionics bay, basically. Okay, I need one more intermission, and then we're going to do the thrust vector control mount. And then we'll see. I don't know, maybe we'll do some more things after that. So, sit tight, do not go away. If you go away, I promise you, you are gonna regret it. look into my eyes. You're gonna regret leaving this stream. Don't leave the stream. Okay, here we go. I'll be back in like 5 minutes. See you soon. Hello again. My name's Joey B. Welcome back to the stream. If you're just joining us, it seems late to be just joining, but I suppose if you're just joining, we're building a Scout D1 rocket. and I have a cough. Oh my gosh, what a great way to open up the stream again. Okay, let's go to the workbench. I have new tea. You'll notice it looks kind of yellowish. The new tea is ginger turmeric. And let's see. It's pretty good. It's alright. I kind of like the orange and spice better. This one's good though. I think it's like an organic brand. Yeah, Simply Truth Organic Ginger Turmeric. It's all herbal tea though. Yeah, I kind of like that one. Not as much as the other one, but I like this one. Okay, looks like urine. I mean, a little bit, but it's tea. I saw someone asking about batteries that I use to power these things. They're actually quite simple. They are these little guys. Usually they don't come with blue tape all over them, but these batteries are 11.1 volt or 11.4. I think it's 0.1. They're 4-cell LiPo batteries, and I think they're like 200 milliamp hour. They're not very strong, or they're not very long lasting because we don't need to fly our rockets for a very long time. And when it idles on the pad, all of the power-hungry systems are basically shut down via the flight computer so that the computer only prioritizes when it has to actually start pulling a lot of power. So that's what it is. It's like 4-cell LiPo batteries. Okay, and what were we thinking of doing? I think we were going to build the thrust vectoring mount into the bottom section of the rocket here. So let's probably get started with that. I need a paper guide for that. And first, let's just look at the chat here. Will I try to create a starship or starhopper? Probably not. I mean, maybe, but probably not. I'm like kind of interested in making scale models, but mostly in building my own. Is BPS Joe's full-time job, or does he have another job? It is my full-time job now. It was not like that for a long time. I was a wedding videographer. I filmed music videos. I did a whole lot of things, but now it's a full-time job. On Reddit, you mentioned an inline reaction control system for high-power rockets. When do you think you'll have a flight-ready application of that? Charlie Garcia and I are working on that, and I'm shooting for the spring, but there are lots of things that still have to happen, so if Charlie's still here, he's still here. I am shooting for the spring. I can't speak for Charlie, but we're both moving forward. It will be 2019. Like, I can guarantee 2019. Oh, I just shot myself in the foot for sure. But, like, 2019, almost certainly. Like, flight test 2019. We'll see. How do you have time to do all of this? I don't do anything else. When will you launch the Scout D1? Hopefully this week. We'll see. Have you learned about rocket nozzle design? Any desire to work with it? Yep, through Rocket Propulsion Elements by George Sutton. Just like one of the main aerospace engineering textbooks that most people look at for rocket design. Nozzle design is cool, but I'm not interested in doing my own right now. 4 cells is 14 volts. I think 14 volts is like the top end of it, so I think nominally it's like 11 something. I don't know, I could be wrong. It's a 4-cell though, that's what it is. Good old blue tape. Thank you, Joe. Oh wait, no, maybe it's 3 cells. Because 2 cells is 7.4, so it's 3 cells. Who is that? Jim, you're correct. You're totally right, man. 4 cells is 14 volts. So I use 3-cell LiPos, not 4-cell. Thank you so much. That's correct. Good old blue tape. Hi, Richard. Okay. I'm missing a bunch of things. Do you need any special permissions to launch these rockets? Not for me, not for mine, because they are below the mass and propellant limits of the FAA. Okay, RCS is done February 6th, then I'll ship it to Joe. Wow, that's soon. Fingers crossed. Can you do a more in-depth discussion on how TVC works? Yes, but probably in a separate video. Do you have a smaller retro engine compared to the launch engine? Yeah, it's actually the same size. I'm working on RCS as well. Nice. as far as the RCS goes, I assume you're flying it at a TRA or NAR launch. Will they announce it ahead of time? I would love to see it. Yep, it'll be probably at an NAR launch. I don't know the exact details yet, but maybe we'll try to get like a bunch of people there to see it. Although maybe not too many, because like you want to make sure it works. We'll do a bunch of static tests of it before too. It will be ready in 6 months. Wait, are you doing RCS? It's CO2 powered. Yep. 3 cells is 11 volts. Yep. What is your 3D printer application? I like Simplify 3D, but it is probably way too expensive, but also it's kind of worth it. Oh my gosh. Okay. Is your printer on carpet? Yes, it is. Non-ideal, but that's where it is. What's the max weight to not register the rocket with the FAA? Depends what you want to call register, but like 1.5 kilograms. What's the largest motor you've flown? An I-175 in Thrusty McThrustface. Yeah, Charlie's right. 1.5 kg. It's TVC time. Let's get a piece of paper to work with our guide here. I'll be right back. Okay, so if you've been sticking around for a while, you might remember this little guy right here. This is a piece of paper that we used to cut out different parts of our rocket. However, we can't use this for thrust vector control because we have a separate paper with different cutouts for thrust vector control. And that's what we're going to use now. Oh, I just remembered this. Okay, I need to go find a semi-assembled thrust vector control mount. I think I see one here. Bingo. Here's a TVC mount. This isn't the one we'll use, but this will be a great placeholder. So you can see it moves different directions. And looks like it's not perfect, but it'll work as a placeholder. Okay, needs more tea. Nice. Okay, so the thing that I want to do is think about using 2 motors in here. So 1 second. This isn't going to make a ton of sense. I'm not going to like narrate it super well. But basically, I kind of want to do like that, or something close to it. So I think I want this like fairly recessed in the mount. Yeah, you know, if it's there, that's not so bad. So we're gonna give it like 1 inch to the bottom. That's how we'll do this. Okay, never mind. This makes sense. Everyone, it's all fine. Oops, this is not rocket related. Oh geez. Okay, hold on. So how are we gonna do this, ladies and gentlemen? I think we have to draw a reference line from up here. Ghost. What reaction did you get to the public when shooting these off? Usually people are pretty cool about it. Ghost. People complain. Oh yeah, okay, the plate moves. They're talking about the 3D printer. Ever see the space art of Abby Garrett? Her SpaceX theme Go for Launch is fun. AbbyGarrett.com. Yes, Abby's awesome. Abby and I are friends. Well, like we're internet friends. But her art is great. She hustles too. She like works really hard. Okay. So, how are we gonna do this? I goofed a little bit because usually I'll set up these 2 guides first and then I'll like work backwards from them. But we sort of went the opposite way here. I think what I might try to do is like this, just to get a nice straight edge. Yeah. This can probably work. Let's try that. Like that doesn't look straight, but that kind of looks straight. It's really hard to tell. Let's give this a shot. If it's off by like a degree or two, that's probably fine. Oh yeah, that's more than a degree though. And you can really, once you like stare down the barrel, you can eyeball it pretty accurately. Yeah, that's pretty close. I think we'll probably do something like that. Yeah, the second line looks good. Yeah, I'll go to like a little bit to the left of it. Okay, this will be fine. It will be fine. It's gonna be pretty close. And again, because these flights are fairly short, you can kind of get away with some misalignment and not worry about it too much. But you can't get away with too much. You'll get yourself in lots of trouble really quick if you have too much misalignment. I'm gonna secure this down right here. Anyone watching any good space shows lately? Every now and then, oh no, oh my gosh. Oh my gosh. I messed it up. Okay. BPS.space! I love SciShow. Anyone who watches SciShow will recognize it. I watch way too much YouTube. It is unhealthy. Okay. This feels pretty good. Let's get some more tape on here. Good old blue tape, as Mr. Richard Mansell says. He's right, good old blue tape. Boom. All right. Now, let's look, everyone. How does this look to... Oh, this looks fine. Yeah, this will be great. And if you line it up here with side one... Oh, where's our avionics? Okay, hold on. Come on. There's side one, and then side one here. Oh yeah, this is perfect. This is fine. This is like plenty in line. Didn't mean for that to rhyme. Okay. So, now what we have to do, I'm going to tape this down a little bit more. Just for like good measure. Okay. What do we do first? Put it in the chat. We either have to cut out the cutouts or drill the holes. Say it in the chat. Either cut out or drill. One of the two. Cut out or drill. You have to put it in the chat. And I'm going to answer some questions. Okay. Scott Manley. What about Scott? Favorite show, Scott Manley. Lost in Space, Space Times, Expanse is cool. Does the live stream count as the show? Yeah, it counts. Why is it made of paper, not PVC? PVC is frangible and also heavy. Does the printer seem slow for anyone else? It's just at a slow speed. It's moving at its own pace. Joe, do you need a Sprite cranberry? I don't think I do. Thank you, though. Has anyone heard of Copenhagen suborbitals? They're awesome. They're like way out at the edge of experimental. It's pretty cool. On a scale of 1 to 10, how much do you work on BPS stuff? 1 equals a few hours a day, 10 equals eat, sleep, BPS, repeat. It's like a solid 8. You know, you want to stay healthy, but like it's a solid 8. What if you 3D printed the tube for the rocket? There's no real point in 3D printing the tube for the rocket. It's kind of inefficient. Boundary layers aren't fun, and it's heavier. It's all around like not worth it in my opinion. Guessing you're an NFL fan. Oh my gosh, hold on. No, I don't care about football at all. Like at all. My mom called me during the Super Bowl and she goes, "Are you watching?" And I go, "What game?" Do you watch The Office? And if so, do you like it? I think, Kyle, I have watched the entire Office, like the entirety of all of the seasons of The Office, the U.S. version. I've seen the British version a couple of times too. It's pretty good, but the U.S. version, I have probably been through all of the episodes 15 times each, maybe more. I love The Office so much. I watch every Stay Astronauts. Okay, drill, drill, drill. Everyone wants the drill. Wow. Some people want the cutouts. Great shows. ATG8. It's coming, apparently. They tweeted at you, JR Craft. They tweeted at you, like, just recently. The G8 is coming. Do you watch Vintage Space? I love Vintage Space. How much is it to be a patron? There are a bunch of different levels on the Patreon. You can go check it out now. Joe, have you watched the Apollo 8 documentary by Paul Hildebrandt? I don't think I have. Okay. Are you planning on making liquid-fueled rockets too? The Office never gets old. How about Doctor Who? I love Doctor Who. I haven't watched it in a long time, but are you an AFL fan? Nope. Okay. It's time to get back to work. Everyone wanted the drill, so that's what we're doing. Democracy prevails. Okay. 3, 4, and 1. And now, time to cut. How's that printer doing over there? Is everyone keeping an eye on the printer? We're definitely moving along. You can start to see the legs forming. How about Psych? Psych is awesome! I love Psych. Psych is a lot of fun. You need to make a Q&A stream. What are the steps to get approval for a bigger rocket? I am probably not the person to ask for that. Can you launch something to space? You can on a balloon. I thought you were drilling into the printer for a sec. The camera moved. I think he's firmly focused on model rockets. Watching the printer is very satisfying. The end screen popped up. The end screen popped up? What end screen? Oh, the error screen popped up. Where did the error screen pop up? Well, I don't know. I don't know what's going on. Stream stuck. Is the stream really stuck? Seems like it's moving. Is everyone good in the stream? It's fine now. Stream is working fine for me. It's back on now. The legs look awesome. Stream is fine now. It's good. Okay, cool. Not here. It's not stuck. Stream is fine. Thank you, everyone. Thank you for using up your slow mode chat to say the stream is fine. Okay, great. It's time to cut these things. Where did I put the knife? What a great question. Here we go. We're gonna start with this top guy because this top guy is pretty easy to do. And I'm gonna zoom in. Let's hope that everyone can see this. Why is this like out of focus? Aha! There it is. That helps. So these cutouts are like little reliefs in the rocket's airframe because the TVC mount fits pretty well in a 74mm airframe, but just like it's not quite perfect and you want a little bit of room for the servos to be able to poke out. So they're little access holes or they're little relief holes in the airframe, and that's what we're cutting out right now. Okay. And one more here. Boom. All right. Now we've got one down here to go. Boy, this desk is getting kind of crowded. Ooh. What is going on? Hi, the Redstone Hive. Just joined the stream. We're building a Scout D1 rocket. Who else just wants Joe to say their comment? By Ben Saxon. Okay, he's been doing these for over a year now. That's awesome. What a time to be alive. Can't believe we get to watch an innovator at work live. Well, innovator is perhaps an overstatement for what I do, which is get things wrong a whole lot until I get them right. Okay, there we go. And then around this edge. It's a good idea to use like a really sharp knife for these. Having a sharp knife is always helpful for this stuff. Makes your cuts cleaner. Means you don't need to go over your incisions like 3 times. Okay, there we go. And one more right here. And then we'll be done with the TVC cutouts. Okay, excellent. Time to take it off. There we go. Okay, and then we'll do some more questions here. Bingo. Very nice, everybody. I was just about to DM you on Insta about your newest video, but I didn't want to be annoying, but I loved it. Thank you so much, Robert. Actually, let me do a little public service announcement here. If you want to get in touch with me, Instagram is perhaps the worst way to do it. I just cannot keep up with the Instagram DMs. I'm so sorry. I try to, but the better way is the contact form on the website. So if you have a message for me, that's definitely the best way to get a response, is the contact form on the website. Ooh, ginger turmeric. Okay. How would you describe yourself as a kid? Were you always interested in different things than other people? Not really. I liked techie things, but I was a pretty normal kid, I think. Do you pack your own... Uh-oh, I've lost a bunch of things. Do you pack your own solid rocket engine? And if not, what brand do you use? I do not build my own solid rocket motors. I use Estes, Apogee, and Aerotech. And whatever works, really. Is the stream buffering for anyone else? I hope not. The printing landing legs look sideways. They are sideways. How small do you think you can make a liquid rocket? You can make very small liquid rockets. The problem is then like lofting all of the hardware associated with them. So there's like a curve, there's like a threshold you have to hit at some point where it's no longer useful to be in liquid rocketry because it's just too heavy to lift all of the tanks and propellant. Focus is slightly out on the overview cam. It should be... oh, the cough. It should be good now. I'm excited about the G8 because I'm building a super lightweight rocket with small deployment system. It sims to about 3 kilometers. Yeah, the G8 is crazy. I think Gary from Aerotech flew something to 3 kilometers on one. Just like a tiny, regular little rocket. He flew it to like 3 kilometers. Have you ever thought about building your SRBs? I have no interest in it. It's working. Some people are having trouble with the stream. Okay. What's the best way to find out about the process of building a smaller scale liquid engine? I'm not sure. Hit up the rocketry forum. Not the rocketry forum. Don't ask about liquid engines there. Hit up the rocketry subreddit. Reddit.com/r/rocketry. If someone wants to post the link, usually people are pretty helpful over there. Okay. What is 3 kilometers in feet? I don't know, man. You have Google. You're on the internet. Okay. So the thrust vectoring mount is going to sit inside here, right in this position. So do we have to cut out anything else? I think we might be like pretty well along here. I don't know. Let's put the TVC mount inside, just for fun. Just for funsies. This one's kind of hard to mount. It's fairly far up in the rocket's airframe here. Come on, buddy. There we go. Now we need 4 of those kind of longer screws, like this. That might be too long. Yeah, like this. Oh, that's all beat up. Like this. Is that gonna work? Yeah, there it is. It's mounted. And this. Another screw. I'll grab this guy right here. This is not a permanent mounting of the thrust vector control system. It's just temporary because we would need to actually like wire it up properly for this to be correct. But we're just doing it as a placeholder right now to make sure everything fits. Where is that it? It's really hard to see. Oh, okay. It's all skewed. Yeah, it's all skewed. There, does that work? That worked. And one more here. Make sure this fits. Perfect. This is why we want to use a guide. It just fits like a glove. Okay, so now we have TVC mounted in our rocket. Excellent. Let's put some screws in here. And we're just going to mount a bunch of things inside of this airframe. It's so nice to work with like a brand new rocket airframe. It's like such a wonderful feeling. I'm gonna slide this up in here. And find some screws to place in there. There we go. We're almost there, folks. So here goes our flight computer going inside here. I want like brand new screws for all of these. Yeah, like this. We're running out of new screws here. There's another one. This one here. Most people have a better organization system for their screws, but not me. I have a bag. Okay, now. Oh no! Oh my gosh, are you kidding me? Oh my gosh, I didn't even mount it in there. It's not even. The screws aren't even like in anything. Oh. Joey B, everybody. Ladies and gentlemen. My name Joey B. I don't know how to screw things in. A round of applause. Just a quick round of applause for me. Because we have to unscrew all of these. I'm screwed. Oh, jeez. This is not the dumbest thing I've done, but it's up there, man. Okay, that is definitely lined up. Okay, that's a secure... That's a secure flight computer now. I can't believe this. All right, almost there. We're getting there, folks. Two more. And then like 6 more. And then like 8 more. Okay, the flight computer is mounted in the avionics bay. So now let's mount the top and bottom sections, or the top and middle sections of the rocket. There we go. That's the bottom and middle. Screw those together. That's another one. One here. And one more. And then the middle and top sections of the rocket. And these are really easy to line up because we spent time making those labels. Uh-oh. Here's... Welcome to what happens when you do integration testing a little bit too late. It seems to me that this was longer than anticipated, and I did not actually plan this out well. Does anyone see the problem here? It's not a really big problem. I can just like cut pieces of this off. But that could have been avoided because I spec'd this out to not have this problem. Okay, well, we're just gonna cut it off. And that is why we do integration testing, folks. So we're just going to cut off an arbitrary amount right here. And this should be enough. And if it is not, we can cut off more. I can't believe this. I mean, it's not really that bad, but like, this is the consequence of building things on a live stream where you're not like completely focused on the build. It's whatever. It doesn't really matter. It's a model rocket. Okay. Also, like, everyone makes silly engineering decisions from time to time. Aha! Perfecto! Where are my screws? I think we're out of them again. We need more screws. Okay, here's one. We need another right here. A lot of screws in this rocket. And one more. Una más. Okay, folks. So this is a really solid base for our Scout rocket. Boy, it feels really good. This is like a very solid vehicle. Yeah, like I feel great about this. Oh, this is really nice. All of these screws are really perfectly lined up too. Like, honestly, this is kind of better than when I do it the right way. I feel like I was meticulous enough with these that it like transcended the usual level of accuracy that I get. So this is really good. Let's do a couple other things while we're here. We might as well. So I'm going to go ahead and put this right there just for a sec. And we're going to clean up a little bit and then focus on some of the landing leg stuff. I hope everyone's down to stick around for another, just a little bit longer. I'm still going, so figure just continue the stream. Okay. So let's go ahead, clean some of these things off. And let's see. What's the largest motor you've flown? An I-175 by Cicerone. Screwing 100. Shakes, sounds the rain chime. Feels really solid. What else? How long do you think you will succeed at landing? Your test launches are really close. I like electronics and making music too. What about a carbon fiber body? That would be light but expensive. Couple of questions here. So how long until I land it? I don't know. Definitely 2019. And that's about as specific as I really can get. What else? I like electronics and making music too. Awesome. Carbon fiber body, not really worth it. And also, that ends up being heavier than the cardboard body that I'm using now. And also expensive, and a little harder to work with. And not great for RF. Okay, so let's go ahead and take some of the support material off. I'm going to try to zoom in so it's easy to see. But we're going to smooth some of this out. So what I'm doing here is removing the support material from the base. And the base here is what really holds the landing legs together. It holds the rocket on the pad, or it helps hold the rocket on the pad. This is like where the rocket sits on the launch pad. So you can kind of think of it like the Octaweb from SpaceX, but not really. Like it doesn't hold 9 Merlin engines. but it does do a lot of the functions that the Octaweb does on a Falcon 9. It's like that type of component. And it takes a lot of support material clearing, but it doesn't break very often, so it's, you know, it doesn't bother me too much. There's a lot of support material here. Someone should ask more good questions, because I need something to talk about while I do this. Wonder how the printer's doing. I can hear it over there. Joe, no support material interface. Arsenio, what is a support material interface? I don't know what that is. There we go. Okay, now this side. What kind of music do I listen to? Honestly, a lot. People say all kinds, and like I don't listen to all kinds. I don't really care that much about country. I like electronic music though. If anyone knows like Above and Beyond, like a lot of the stuff that they curate is pretty cool. Especially when I'm coding, like deep house is really great, or progressive stuff. You know, the songs that last like 8 to 15 minutes, those are great. Music is like, can be used as like a tool to just trick your brain into doing lots of work. If you get the right music and you like figure out what works for your brain. Come on, support material. What did Arsenio text me? It makes removing the material super easy, clean detach with low effort. I would like that. Well, I bet we can just drill it out for some of this. Yeah, like that can be drilled out. Same with this. There we go. Actually, yeah, this works pretty well. Just trying to clean it all out here. Nice. I wonder if this is interesting for anyone. Okay. Get all this material off. I'm actually pretty close here. I have like a couple other things to do. All right, yeah, that looks good. Did I miss anything? No, I don't think I did. So now we just need to get these other two right here. Almost there. And uh-oh. Okay. Well, this one's kind of stuck in the middle part there. This is where the rubber band wraps around to pull the landing legs down. Okay, well this is close enough. Mostly what I wanted to do is just mount it onto the rocket to see how it looked. So let me remove this piece and this piece, and we'll mount it onto the base here. Okay, so this is basically what happens with this piece. It goes on the base here, and then the rocket sits on it. And so it provides It provides this really solid surface for the rocket to sit on while it's on the pad. And then it also, because it screws in so many different places, look, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 different screws for this one piece go through the airframe. So it's like a really rigid and solid connection into the bottom of the rocket. And so through that, that's why it's okay for this to hold the landing legs, because it sees a ton of force when the rocket impacts the ground with those legs. So for the first flight, we'll fly it with landing legs, and we'll try to, have it land standing upright, but it's like very unlikely. Okay, what else? Where's my tea? Yum. Okay, well, let's see. Let's look at some questions here. Send me your questions now. I think we're probably in the question portion of the stream as we sort of wind down here. Have you tried printing without support? Yeah, actually, you know what? Printing without support would probably work fine for this object. I should give that a shot. Can you control the thrust on the engine? If not, would it ever be possible to land? I cannot control the thrust, or I do not. There are ways that I could, but I don't. And it is still possible to land. You should check out the first 2 videos in the Landing Model Rockets video series to see how. The landing legs look cool, thank you. My rocket was painted candy apple red metallic, very cool. Yellow accenting. Pronounced niche. Niche. I think that's, some people say niche, but I think niche is the way you say it. Let's see. How often do you stream? This is the first one I'm catching. Not very often. It would be good to stream more often, though. I mean, it's like fun to interact with people and just hang out and talk rockets. So maybe I would hope to do more often, but I don't have like a schedule. Do you get a crowd of neighbors during test launches? Does it make you nervous? That's a great question by someone named W, just the letter. Yeah, sometimes people will come up to the launches. In the most recent Echo landing test, there was one other guy there at the field. He was flying like an RC plane, and as soon as the test happened, he came over to be like, "What's going on here?" And he actually knew who I was. He had seen the Vice video, and he was like, "Yeah, I saw your thing with the interview and everything." But it does make me nervous. I don't invite people to launches. There are a very small few exceptions, but I do not invite people to launches just because it's such a stressful event that I kind of want to just be by myself and only focus on the checklist and the rocket. Hi, huge fan. Do you think relocating the rocket motors with the nozzle up to the top would have a natural stabilization and would not require such a complex inverted pendulum type control system? By Shakaib. I hope I'm not pronouncing your name wrong. So, this is a great thought. This is a thought that a lot of people have had with rockets. Why don't you put... So, like, the problem right now with how this flies is you fly it like a broomstick where you balance it on your hand, right? You're trying to keep it upright, and you're doing that by pushing little forces into a thrust vector control mount on the bottom, and it's kind of hard to do. So what if you put the motor on the top of the rocket, right? Because it's always pushing up, and it just would swing back to the center. Well, this is called the rocket pendulum fallacy. And you can look it up. There's a whole Wikipedia article on it. And even Robert Goddard himself, like the godfather of rocketry, and especially the person who invented the liquid rocket engine, fell for this. So the rocket pendulum fallacy is essentially that when you are holding your rocket like this, your rocket is being pulled on by gravity, but each part of this rocket is pulled on equally by gravity. And so when you move it like this, you're moving where the hinge... It's going to be hard for me to describe this. Essentially, when I'm pulling the rocket up, I don't care which way the rocket is pointed, I'm just pulling up. But when the motor is up here and producing thrust, the motor is always thrusting along the longitudinal axis of the vehicle, or the z-axis, whatever you call it. It's always thrusting along whichever way the body is pointed. So the extreme example of this is if your rocket... Oh, and the other important thing is every part of the rocket is affected equally by gravity. So as your rocket goes up and the motor is pulling on the top of the rocket, if it starts to, and it will because there are just imperfections in motors, as it starts to tip over, like this, the rocket motor isn't pointing back towards gravity, it's now pointing this way. So the rocket is just going to slowly arc over. You can see this in, if you build this in like Kerbal Space Program or something like that, you can actually see this in action if you turn off all of the stability systems. So it's called the rocket pendulum fallacy because in your head, it seems like you've figured something out that like no one else has thought of. Just put the engines up top. But as it turns out, some people have tried that and it turns out to not work. So it's a good thought though. Okay. Can we rewatch this stream? Hi from Minnesota. Ooh, that's cold up there. Yes, you can. It will be available to watch, maybe not directly after. Sometimes it has to go unlisted for a little while, but it will be. Will you ever try to take a PPL, a private license? If so, where? I don't know where, but I would love to get my private pilots. But it's just super expensive. I don't have the money for that right now. Vertney sends me a shark. Thank you for the shark. How high do you think the finished rocket will go? I don't know. 60, 80 meters maybe? Depends on what we fly it on. What is the shortest time you have printed landing legs? Oh man, I'm really behind. Oof. I'm really behind. Sorry, folks. I don't know, an hour, maybe 2 hours. Any pets? No, but I want a dog. Would a variable engine allow for thrust control? Yes, but it's very hard to build at this scale. How long are the legs compared to the rocket? I think they're about 150 centimeters. When will you begin to sell some finished reusable rockets? Every model rocket right now is reusable. But I don't know. It honestly may never get to the point where I can sell the retropropulsive landing rocket just because it's so unbelievably complicated. We'll see. I have to do it first too. Like I have to actually prove that it's possible. Has it been 8675309 hours yet? Nice, Keon. I think it's almost that long. Can you do a Joey B food review? No. Technology used for streaming, just like webcams and stuff. Okay, favorite NASA rocket, Saturn V. What are your long-term plans? Where do you see yourself in 5 years? Oof, I don't know. I mean, I have plans, but like too long for now. What is the max dimensions for the motors in the thrust vector control? Diameter and length. Length is pretty flexible. Diameter is 29 millimeters. The pendulum fallacy. Why don't grid fins work? Boundary layer ingestion. You can look that up or think about it long enough too. It's just hard for them at this scale to ingest all of that air effectively through the lattice structure of the grid fin. That's really a fancy way of saying the air don't move so good. I'm losing steam. Where do you get your inspiration? I don't know, man. I just really like rockets. Physics don't like that. How do you deploy the landing legs? Sorry. How? I really need to catch up. How do you deploy the landing legs? Do you still use rubber bands? Yes. That's why they have polar motors on launch abort systems. Just because the polar motor is better up top. And the launch abort system is naturally aerodynamically stable. So, I don't know, actually. But it makes more sense engineering-wise to put the motors on the top. Because you don't want to shoot a bunch of fire into the capsule that you are trying to pull away. What if you had signal alpha at the top with the engine? I suppose that could work. Do you control z-axis rotation and how? On the Falcon Heavy I do, but otherwise no. Do I like Star Wars? Yeah. Will the TVC mount back in stock? Will the TVC mount be back in stock? If so, will we be able to buy it separately? It will be back in stock soon, and you will not be able to buy it separately until it's released on Patreon, which might be a few months. Okay, I have to skip a couple. What is 80 meters in feet? I don't know, man. Why do people ask these questions? You have Google. Like, this is not... You have Google. That's all you have to search in Google is what is 80 meters in feet. How did you learn to code? Lots of YouTube tutorials and lots of trial and error, and mostly error. If I pass a medical, I promise you if you want to take a ride out in a rental Cessna. That's awesome. Thank you. What would your company do with $1 million US? Buy 1 million. Buy 1 million things off of the 99-cent menu at McDonald's. You can have my dog. Thanks, Jen. Have you used binary code before? I mean, in a sense, everyone has used binary code before. How long were you streaming? I took a nap, went shopping, had dinner, and find that you're still here. Can you do a gimbal system that can swap out rocket engines in flight? Sort of. The Falcon Heavy does that. How do you sleep? With my eyes closed. Where would you rather work, SpaceX or Rocket Lab? Rocket Lab right now, because I would end up getting a larger chunk of the company in terms of like stock. But that's mostly the only reason. They're both great companies. Couldn't you use an H motor? Oh my gosh, how can I ever catch up to this? Couldn't you use an H motor if you wanted? Sure, yeah. Have I ever seen a real launch? Nope. I wish I did. Okay, I have to skip a couple more. Will you eventually try to land at a specific spot? Yes, I will, but one step at a time. Or Joe could buy so much of the 99-cent stuff on eBay. Could you integrate air brakes like the Falcon 9? You could, but the Falcon 9 doesn't use air brakes. They use grid fins. So you need a restoring force. That's the most important part, is you need a force so that when your rocket tilts this way, something is pushing it back. So that's why I use the traditional fins. How do you like MATLAB compared to other programs? Have you only used Simulink? Yeah, I like MATLAB, but also like my dad works for the MathWorks, so I had an opportunity to like get started and also have a mentor in MATLAB. So it's one of those things where like my situation has made it beneficial for me to use MATLAB anyway, but I like it. Joey B, how are you? Long time no stream. Hi, Bluegill Bronco. It's been a while. Have I ever met Elon Musk? Kind of. I don't know. We went to the Hyperloop competition and he was there, but like not really. How do your launch pad clamps work? They work exactly the same as the Saturn V launch clamps, or they're a similar design. And those files are published, or the at least the Saturn V launch clamp, like the schematics are online. Let's ask so many questions that Joe never catches up. Oh my gosh. You haven't seen a launch? Come to Florida. What state do you live in? I live in Tennessee. I'm definitely going to a launch in 2019. I'm thinking it'll be worth it for me to fly down or drive down for Falcon Heavy, the second launch. And I might do DM1, but we'll see. Oh my gosh. Landing legs coming together. Yes, they are. How do you calibrate PID controllers that I assume you use? I built a simulation of how the rocket works and how it flies, like a plant model in MATLAB, and then I basically do a lot of experimentation. I would like to use the PID tuner tool that MATLAB has for PID tuning, but I found that I've had a lot of trouble getting it to really work reliably. So it's mostly experimental, just run a bunch of simulations, almost like Monte Carlo style, until you find an ideal set of gains that work. Is the signal open source, and if not, when will it be open source? It's not open source, but if you are looking for something to write code along with, the blip and blop flight computers will be semi-open source through Patreon. Okay. What part of Tennessee do I live in? Nashville. I think I have to call it, folks. My voice is going. We did a lot of good work on this, though. Look at this thing. It's huge. So, this is going to be the Scout D series of rockets. I'm hoping to fly it this week. I'm going to do a bunch of work on it tomorrow. I don't think I'll stream it just because I need to like be a lot more efficient with my time tomorrow. But thank you all so much for joining, and thank you for asking a bunch of nice questions. Some of them were not nice, but most of them were really nice and thoughtful. I don't know what else to say. It's great to be doing this stuff, and I'm really thankful that I'm here. So thank you all for joining. Really appreciate the support. Thank you all for sticking around, especially the people who have been here since the beginning of, well, the beginning of BPS or the beginning of this stream, either one. It's much appreciated. So anyway, have a good night or a good morning, depending on where you are. And I think that's it. So keep your fingers crossed. Hopefully we're going to see a launch of the Scout D series soon. And if you want to follow along, the place that I'll be posting the most updates is either the Instagram story for BPS.space on Instagram, or just on Twitter as text or photo updates. So you can follow both of those if you want. And thank you very much for joining. Have a great night. May your skies be blue and your winds be low. Good night.